Welcome back. Today we're going to talk about unit rates. There's a lot of common unit rates that we're familiar with, such as statistics where you see points per game or rebounds per game, or driving cars, miles per hour, how fast you go. In the grocery store, you see cost per pound or cost per ounce. And obviously something when you look at when you start buying a car, you want to look at the MPG or the miles per gallon. So let's look at what unit rates. Before we can really talk about unit rates, though, we need to talk about fractions. Well, hopefully we all are familiar with fractions. I know we often hate them, but they're really, really important when we deal with rates. A fraction, as defined, is part of a whole, and the top is the numerator, the bottom is the denominator. Just terms to be familiar with as we continue to talk. A complex fraction, I know some of you think complex, it can't get any worse, but a complex fraction is where you have a fraction within a fraction. So either the numerator or the denominator or both contain a fraction. So here we have 3 over 1/4 or 3/8 over 5. The last one shows one with a numerator and a denominator fraction, so 2/3 over 1/2. Now don't worry, although they're called complex, they're not too hard to deal with. How do we evaluate these complex fractions? Well, evaluating them is just dividing fractions. And I know we are good at dividing fractions because we all remember to use the reciprocal on the second fraction. So let's look at these a couple examples. Here we have 3 divided by 1/4. So I said it's the same as dividing a fraction because remember a fraction bar is just a division sign. It's another way to look at it. So 3 divided by 1/4. Well, when we divide fractions, both numbers we want to think of as fractions. So remember, 3 over 1 is the same as 3. So 3 over 1 divided by 1/4. And then we use the reciprocal and multiply. So 3 over 1 times, well, the reciprocal of 1/4 is 4 over 1. And then we just multiply straight across. 3 times 4 is 12. 1 times 1 is 1. So 12 over 1 or 12. Okay? Second example, 3/8 divided by 5. And the way you can kind of tell is normally the fraction bar is a little bit bigger when we deal with complex fractions. So in this case, you notice under the 8 it's a little bit bolder, a little bigger. That kind of tells you where the divide is. So again, we have 3/8 divided by 5. And again, 5 is not a fraction, so we can say 3/8 divided by 5 over 1. And this helps us find the reciprocal, flip our fraction. 3/8 times 1/5. 3 times 1 is 3, 8 times 5 is 40. 3/40, and that is in simplified form. Now our last example, we have 2 fractions. 2/3 divided by 1/2, and this almost makes the process easier as we write it out. 2/3 divided by 1/2. Flip the second fraction. Here's our reciprocal. 1/2 is the same as 2 over 1, and then multiply. 2 times 2 is 4. 3 times 1 is 3. So we have 4/3 or 1 1/3 if you're a type of person who likes mixed numbers over fractions or improper fractions. So that's just complex fractions. It's just division. I know you guys can handle it. Now let's actually get into what we're talking about today, ratios, rates, and unit rates. A ratio is a comparison of two numbers by division. You always want to try and use the same units when writing ratios. So 2 baskets made to 5 baskets made, 2 boys to 3 girls, where we're talking about people. You know, if you're using measurements, you always want to use meters on top and meters on the bottom. So use the same units. A rate is when you have a ratio, but now you have 2 different units. So here you can see dollars over ounces. Okay, there's 2 different units. We're talking about money, and then we're talking about weight. So that's what a rate is. The difference between a ratio and a rate. A ratio talks about the same units, and a rate compares 2 different units. Now a unit rate, we think of a unit cube or a unit square is 1. So a unit rate is just a rate with the denominator of 1. So here we have an example, 55 miles for 1 hour. And that's one of those common rates. If you've been in the highway with your parents in the car, you know 55 miles per hour is the speed limit. So that means you can go 55 miles in 1 hour. That's what that unit rate means. Calculating unit rates is super simple. Everyone can do this because we all know how to do division. So let's look at our first example. We have 1850 over 5 pounds, and we want to figure out what the price is for 1 pound. That way I know what I'm paying and I can compare things. So we have 1850 over 5 pounds. Well, the best way, we need to get the denominator to be 1. Well, how do I take 5 and turn it into 1? I divide it by 5 because 5 divided by 5 is 1. So what I do to the top, I always have to do to the bottom. That keeps it equal. So divide 5 over 5 and I get 3.7 over 1. Now, we don't say $3.7. We say $3.70 for 1 pound. And then you should be able to say that out loud so you can explain your answer. That means I'm going to pay $3.70 per pound or for 1 pound. Let's look at the second one, miles per gallon. So this is how they would calculate your MPG. You have 400 miles you can drive on 14 gallons. Well, we need the denominator to be 1. So we're going to take both the numerator and denominator and divide it by 14 because that will make 14 divided by 14 is 1. 400 divided by 14 is 28.6. So we're going to drive 28.6 miles in 1 gallon. That's pretty good MPG. Last, we have $11 over 4 boxes. Means we're going to try and find out how much money we're going to pay per box. Excuse me. So we're going to divide both the numerator and the denominator by 4 because when we divide 4 by 4, we get that denominator of 1. Really important. And then we have 11 divided by 4 is $2.75. So we pay $2.75 per box. That kind of, again, lets you know what the deal is. So I have some for you to try. I want you to write these down and try these and pause the video. And when you've completed them, play the video again and check your work. I really want you to try these problems on your own. That way you're seeing if you're learning what the video is talking about. Well, hopefully you paused the video and you didn't just let it play through. Let's take a look at a couple of these. Here are the answers we have, and I apologize if the bottom one is a little more difficult to read. But for 100 miles in 14 seconds, that means we're going to go 7.14 miles per second. And obviously that would vary depending on how you round it. $5.76 for 8 ounces means you're going to pay 72 cents per ounce. And if you score 55 points in 6 games, that means you're scoring 9.2 points per game. Make sure when you use unit rates, you can describe in words what your answer says. I don't want to just see 7.14 or 7 and 1400ths over 1. I want to know what that means. That means 7 and 1400ths miles per second. Or I don't want to see 9.2 over 1. I want to know it's 9.2 points per game. That makes much more sense to me as an answer. Let's look at a couple word problems because we know we always have to be able to use this. So Mark is wrapping presents. If he buys 3.5 yards of wrapping paper for $16, how much does the paper cost per yard? Well, when we think about this problem, we want to know per yard. So that means yards needs to go in our denominator because we want to know for 1 yard. So when we set up this fraction, you can see here we have $16 over 3.5 yards. That's our rate right now, $16 for 3.5 yards. And we talked about this being division, so it's 16, and then I converted 3.5 to 7 over 2, an improper fraction, which then becomes one of those wonderful complex fractions where we divide 16 divided by 7/2, and we're going to divide 7/2 divided by 7/2 on both because our denominator will become 1. And 16 over 1, and we're going to find the reciprocal, 2/7 equals 32/7 over 1. And then because we're talking about money, made it into a decimal, 4.57 over 1, or $404.57 per yard. Now I know that looks confusing, so if you're struggling with it, stop and look at it again. Or there's a simpler way to do it, and this is where our mathematical brains can try and come up with faster ways. Well, we know 3.5 yards is the same as 3.5 yards. And because we want to deal with decimals in the end, because we're dealing with money, it's okay to make that conversion right away. So if you see here, I have 16 over 3.5, and then to get the numerator of 1, I just divide the top and the bottom by 3.5. Using a calculator or long division, I still get $4.57 over 1 yard, so $4.57 per yard. I'm okay with you understanding you can convert to decimals. It doesn't always have to be fractions. Use logic and common sense. What would be more logical in this problem? Finally, one more problem. If Joanne can read 18 pages in 30 minutes, how long will it take her to read 63 pages? Now, most of you probably thought proportions. Well, at least I hope you thought proportions. But if you didn't, let's take a look at how unit rates could work on this. So, 30 minutes for 18 pages means that I'm going to read 1.7 minutes. It's going to take me 1.7 minutes per page. Now I'm going to read 63 pages. So I'm going to take my unit rate, 1.7 minutes per page, and multiply that by 63. That's going to tell me it's about 107 minutes for 63 pages. Now these are rounded answers because 1.7 isn't exact. Unit rates work here, but my hope is that you remember proportions because proportions give us a better answer. So you have unit rates or we have the proportion. 30 minutes for 18 pages is how many minutes for 63 pages? Use our cross products and get 1,890 equals 18x, and then we are going to cancel that coefficient by dividing by 18, and we get 105 minutes for 63 pages. Notice that using proportions actually gives us a more accurate answer because we're not rounding. Using unit rates is really good, but don't be afraid to use proportions. We spent so much time on that last year that it is a great thing that you can remember and apply. Well, I know this was a little bit longer than anticipated, but I want to say thank you for listening, and hopefully this helped you recall how to do unit rates. Have a wonderful evening.